So we want to find where this function is concave up and concave down and to identify any inflection points. So inflection points occur where the second derivative, or may occur, where the second derivative is either 0 or undefined. So we need to start by finding the second derivative. So the first derivative would be 8x cubed plus 120x squared plus 600 x to the first minus 24. Okay, so we need to differentiate that to get 24x squared plus 240 x to the first plus 600. Okay, that exists everywhere, so we're going to set it equal to 0 and solve. And I'm going to see, I should be able to take a 24 of everything, I think, out of 600. Let's see. So I'm doing 600 divided by 24 is 25, yeah. Okay, so then that would leave me with x squared plus 10x plus 25. That will factor, looks like, into x plus 5 and x plus 5. Or we could write that as x plus 5 squared. Okay, and that's still the second derivative. I haven't changed anything. I even carried the 24 along the whole way. So I'm going to circle that because I'm going to plug into that version of the second derivative when we go to test concavity. Now, solving this equation, we divide both sides by 24, so that goes away. Take the square root of both sides, that goes away. You get x plus 5 equals 0. So x is negative 5 is my only possible inflection point. And we're going to find out if it's 1 or not, and also determine the concavity of this function by plugging negative 5, or by putting it on the number line and testing concavity on either side of negative 5. So I'm going to take maybe f double prime of 0. How about negative 6 there? And f double prime of maybe 0. Okay, plugging into that simplified version or the unsimplified version, either one. We'll see negative 6 plus 5 is negative 1. Squared is positive times positive 24. That's positive. So f is concave up there. F double prime is 0. Well, 0 plus 5 squared is also positive. Anything squared is positive. So that's also positive. So f is also concave up on that interval. Okay, so it's concave up on these two intervals. It is not concave up at x equals negative 5 because the second derivative is 0 there. It's not positive. And actually we have an inflection point at x equals negative 5. So let's go try that out. Concave up on negative infinity to negative 5 and negative 5 to positive infinity. Okay, and then we have an inflection point at x equals negative 5. So, whoops. Oh, no, sorry. What am I saying? There's not an inflection point. I don't even know why I said that. Because the concavity didn't change, right? It's concave up before negative 5 and concave up after negative 5. So there is not an inflection point at all on this function.